So welcome to my video tutorial on A-level indices. What I'll be going through today is going through some of the basic rules of indices which you would have done at GCSE, but also taking up a notch on some of the things that you may not have spent too much time, depending on what level of GCSE you looked at, and looking at the type of how questions are written. So I'll be honest, the types of questions you get on indices at A-level is a little bit more difficult, but only a little bit. It's more of a case of how the questions are written and the words that are being used, which I will definitely go through in this tutorial. I'll also go through some example questions and give you some questions for you to try, and I'll post up the answers for you to check whether you're getting them right. So what I've written down here are just an expansion of some of the laws that you may have been taught at GCSE. What I've done is I've written them down in all its formations to make it easier for you to one, recall, remember, and obviously put into practice when we move on forward. Now, key things to remember with regards to indices, although it may seem like a very basic topic and it's very, very similar to what you've been taught at GCSE, it does come into play as common sense and common knowledge with more complex topics. You'll see this revisited when we look at differentiation integration, where questions might be slightly different, but the understanding is something that is expected of you rather than something that you'd get marks for. So going on forward from this, if we just look at the first two rules, which you should be familiar with regardless of what level you worked at GCSE. So when the base numbers are the same, so what we mean by the A, and you're multiplying, then all you need to do is simply add the powers. So a to the power of b times a to the power of c. Because a's are the same and they will be the same, we can just simply add the powers when we are multiplying, and likewise when we are dividing we do the opposite of that. So if the base numbers are the same and we're dividing, we take away the powers we get there. Now, one thing that's worth noting, in a textbook they tend to sometimes be written like this, or in a GCSE paper they'll be written like this. However, once you start going into A level, they'll acknowledge that one of the rules of algebra is the fact that you don't use division symbol, you write as a fraction. So if you do get this sort of notation here, the key thing to remember is still remember it's division. So here we would take the power of the numerator and subtract that from the power of the denominator. One of the other basic rules of indices is when you have brackets, so a to the power of b to the power of c, what we do there is we multiply out the bracket, so we end up with a to the power of bc. One of the reasons, and if we're just doing a quick example of what that actually means by that, so for example, if I had a squared cubed, then what that means is that would be a squared times a squared times a squared, and abiding by the first rule of indices is we add the powers together, in which we get a to the power of 6. And obviously a much quicker way of us getting to that answer rather than writing this all out is just to simply multiply out the two powers. Now, a different formation for that is a question I always used to set my students when I'm teaching, is this one. There's always one student who gets this wrong. So when you have got a constant inside that bracket, along with a base number with a power attached to it, and you're raising that to another power, then the key thing to remember is you also need to raise that constant by the power that is outside. So if that doesn't make much sense, then we just put that into an example question. So for example, if we had 3x to the power of 2 cubed, so here what that would be is it would be 3 cubed times x, and then again binding by that rule is that when you've got brackets times the power, so that'd be x to the power of 6, which then becomes 27x to the power of 6. So the key thing there is always remember to multiply out, to raise the number inside the bracket by the power that is outside. So the key thing there is not to think it's just 3 to the power of x, 3x to the power of 6. You'll lose some marks if you did that. Going on to law number 4. Again, anything to the power of 0 is 1. And with regards to step 5, anything to the power of 1, it's just itself. Now I've added on there, which may be questioning, is why have I put a to the power of 1 equals a to the power of 1, is when people do see a single letter, they always forget that it's to the power of 1. So for example, if they had a to the power of 6 times a, they forget that that's to the power of 1, so it should be a to the power of 7. With you picking A-level maths, I doubt very much you'd make that mistake, but it is something that can be identified as a silly mistake or a classic mistake, as we sometimes say in the teaching world. Moving on to step number 6, or law number 6, anything to the power of a half is the square root of that base. Anything to the power of a third is the cube root of that base. Anything to the power of 1 over k, obviously at A-level, at GCSE there always used to be, the denominator either used to be 2 or 3, but when you get to A-level it could be absolutely anything. So if you did have a value of 1 over k, then it would just be the k root of that base number. If you were to have like 1 over 5, which is completely and utterly feasible, there's a function on your calculator that allows you to do sort of multiple roots of a base number. If you just press the shift function and look out for something that's got like x root or an empty box with a root, and then you type in the base, you can fill in the numbers and you go from there. Another one that's regarded as high level is negative powers. So the key now, again, when people think negative power, is a common mistake that people make is they just make it negative, which is not the case. But basically a negative power means the reciprocal. And what this is just a more advanced way of dividing numbers by multiplying. And I know that sounds like a bit of an oxymoron where it's with an opposite and a complete opposite with a word that's attached to its opposite, is just that. So here, if I was to say to you, what is the opposite of multiplying by 2? A lot of you would say it's dividing by 2, but I could also multiply by its reciprocal and I would also get the opposite. So when you talk about inverse, it's about doing the opposite. So here the opposite of multiplying would be the multiplied by the reciprocal. So anything to the power of minus b would just be 1 over a to the power of minus b. And again, a very, very common thing that you need to make sure you don't mess up on is just that. Moving on to step number 10. So again, just formation with regards to fractional powers. So when you have got a fractional power, the numerator refers to the power, and I don't know what's happened there, happens to the power, and the denominator is the root. Now, a common question that I always get asked is, which one do you do first? So if I did have a fractional power and they were all numbers and one of them wasn't 1, then what do I actually do? Well, there is no cardinal rule of this. It shouldn't really make a difference, but you would tend to find that one is definitely going to be easier than the other. So for example, if I had 27 to the power of 2/3, now what that equals, it equals the cube root, because the denominator is 3, 27 squared. So I've either got to choose whether I square 27 and then cube root it, or do I cube root 27 and then square it. Now, you've got to decide within yourself which one's going to be easier. There'll always be one that is easier for you, but with the A-level paper being calculated, it shouldn't really make a difference. So here, what we would do is we would cube root the 27 first. So if I do this first, I would get 3, and then I've got 3 squared, which would then give me the answer of 9. So from that, what we can then do is go from there. So you would tend to find that if you do have fractional power, one would definitely be the easier to do first. But like I said, it shouldn't really make a difference. It all depends on how you've entered it on your calculator if you have done that. Now the next thing that comes up is this one, which is probably the most complex of combinations or an amalgamation of some of the more higher level rules, is what happens when you've got a negative fractional power. Now again, it's just that. You just write it out in its step. So the minus means it's the reciprocal, so 1 over. B, therefore, then you look moving on to the denominator. So if you ignore the minus, all of this would be on the denominator. So just that would be the denominator. And obviously, reading by this little bubble here, it says that the numerator would be the power, the denominator would be the root, and we go there. So for example, if I had, mix the colours up, so if I had a to the power of minus 4 over 5, then what that would be is 1 over, which deals with the negative. I've got the 5th root of a to the power of 4, and there you go. I'm not going to say you can't simplify that any further because we're dealing with algebra, but that is basically it. So it's important that you're able to recognise these rules and recognise the steps, but also not just going from the left hand side to the right hand side. You've also got to manipulate it to go from the right hand side to the left hand side. Although indices questions don't really carry that many marks at A level, it is definitely something that is used in other subjects. So I will definitely spend some quality time while you're getting started in your A-level maths to make sure you are comfortable with indices. So the next thing we move on to are keywords. Now, one of the things that you will notice when you move on to A-level is that the questions are worded slightly different, the layout is slightly different, and there are key things that you need to understand of what it is the actual question's asking for. So all I've done here is I've gone through some of the common questions that get asked related to indices alone, and these are the kind of words that pop up more often than not. So if we look at the first ones are evaluate, let's get rid of that. Evaluate and calculate, which basically means the exact same thing. And what you'll find is that if you are asked to evaluate or calculate something that involves indices, then what it will do is ask you to find the numerical value. Now, with your A-level paper and your calculator paper, it might be as simple as just plugging it into your calculator. It might be one of those multiple choice questions that you might get next to. But I would say more often than not, evaluate, calculate tends to come more in textbook questions when you first start to learn this topic. Moving on to the word simplify, so this is where you are using the rules of indices like described above, and generally speaking your answer would be as written as a single term, but again, do not hold me to that. Sometimes it does change, but you are going to be using rules of indices to try and write it as simply as possible. The next thing we move on to is solve. So very, very similar to solving equations. So with this, what you'll end up is with a question. So for example, where you've got to find a value of a letter. So if I had, let's say 3x is equal to 81, I've got to find, how can I write 81 as a power of 3? So I think, well, how many times do I need to divide 81 by 3 until I get to 1? So that answer there would be x equals 4. So that would be an example of where you've got to solve an equation. So this is what your answer should look like, is where you've got the value of what the letter actually represents. Moving on to proof, and again, this is a topic that students quite not like, is when you're asked to prove something. So these types of questions are where you are given the question and given the answer, and what the question is asking for you is to show your full working out step by step of how you get from the question to how they want in the exact same format. Now, the general rule of this, and we'll go into more detail when we look at proof questions, notably in trig and using trig identities, but you would take the most complicated side and try and make through using rules and knowledges and theories and identities, you would then show that it can be written in the same format as the right hand side is written. So just make the left hand side look like the right hand side and you are good to go. Now, one thing you may notice, now this doesn't really come up in A-level papers, but something that comes up in textbooks, is rewrite in index form. Now, what you are doing here, this is where you are given the opposite of what the laws are. So where you're given the right-hand side, and you need to write it in the left-hand side. So, for example, you could have something that looks like the cube root of x to the power of 61. I'm going to put that so it doesn't simplify the fraction. So how this would be written in index form is it'd be x. Now, because we've got roots and powers, it's going to be a fractional power. So then what that would be, it'd be 61 over 3. And I'm hoping that doesn't simplify it because I've tried to make sure that it isn't. So that would be an example of rewriting index form, is where you're given something like this and you need to abide by the rules of indices to work out what it actually is. And so these are keywords that you need to look out for when you are working through indice questions. So what I'm going to do now is I've personally written down a selection of mixture of questions that you are likely to face. The key thing to remember with regards to some of these questions is in A-level paper, don't expect to get the hardest type of question from each topic. There will be some nice easy questions just to ease your anxiety when you're doing an A-level paper. There'll be a fair few multiple choice questions that are only worth 1 mark. So try not to focus all your time on the more complicated questions of each topic. Don't forget the basics, because it's from the basics that you're able then to do the more complicated questions. So what I recommend that you do, that if everything that I've mentioned already made sense, then I'd recommend you pause this video, have a go at some of these questions, and what I'll now do is go through some of the answers of what you should have and talk you through how I've got some of the questions and key things to look out for to stop you from making any future possible mistakes. Right then, so if we look at question 1, so question 1 is just evaluates. All I've got to do is actually just work out these questions or represent what they mean. You might have to do a little bit of working out. So for example, most of them will be worth only 1 mark. Some of them you can easily just type into your calculator, but what I'll do is I'll just imagine I haven't got a calculator with me, and we'll go from here to explain what they are. So with regards to A, this one's just 5 cubed, so 5 times 5 times 5, which you should have is 125. For B, 11 to the power of minus 2, so that's going to be 1 over, because it's a negative power, 11 squared, which would therefore be 1 over 121. Would I ever leave it in this form? No, because we know what 11 squared is as A-level students, so you should be able to write it out and go from 101 over 121. For C, this is where we start moving into fractional powers. So what 8 to the power of 2/3 is, it's going to be 8 squared cube rooted. So here, 8 squared, you should know. Cube root of 8, you should know. So it's entirely up to you which one you go for, but either way, you should get the right answer. I'm going to go for the cube root, because you tend to do the roots first before you do the power, although don't quote me to that one as being law. So here we've got 3 cubed. So if I just get a different colour pen, just so you can see what I'm doing, I do first. So for example, I'm going to do those two there bits first. And so cube root of 8 is 2. So I've got 2 squared, which therefore gives me 4 as my final answer. For D, what I'm going to do is just rub all of this out and just give me a bit more space. So with regards to question D, I've got 3 and 1/16 to the power of a half. So again, going through the question looks complicated because we've got a mixed number in here. So one way to get around that is to write that as an improper fraction. So 3 times 16 plus 1 gives me 49 over 16. That to the power of a half. Now if you remember from the rules, anything to the power half just means the square root. So I've got the square root of 49 over 16. Square root of 49 is 7. Square root of 16 is 4. Can't simplify it any further, so our final answer is 7 over 4. Then finally for question E, we've got 16 to the power of minus 3/4. So again, writing down what that means, it means 1 over the 4th root of 16 cubed. Again, do I know what 16 cubed is? Not off the top of my head, not without using a calculator. However, I do know what the 4th root of 16 is, which is 2. So that becomes 1 over 2 cubed. And that then becomes 1 over 8 as your final answer. Moving on to question 2. So again, here we're simplifying, and it obviously now introduces some algebra. So if I just get rid of this, just bear with me. I'm sure there's a quicker way of doing this, but there we go. So let's change the colour of the pen just to mix it up a little bit. I'll go for it. Right, so with regards to question 2, here we're moving on to algebra side. So we've got, when we've got brackets, we multiply the powers, so that one's just going to be x to the power of minus 12. For B, again, remembering this, I used to call it as a challenge to my class. So this would be 3 to the power of 4 times x, and then multiply the powers becomes 12. So all we've got there is 81x to the power of 12. For C, again, we can write this as a fraction. So if I write this as 8x to the power of 4 over 2x to the power of 6, changing the colour. In which, if I simplify this, I can cancel 8 and 2 turns into 4 and 1, dividing both numbers by 2, and I take away the powers, which gives me then an answer of 4 over x squared. And what you need to start doing is getting used to writing this using indices. So what this then becomes is 4x to the power of minus 2. Now if you're not sure where that's come from, is obviously I can write this as 4 times 1 over x squared. This bit here then becomes x to the power of minus 2, which is where this then comes from there. And that's that one done. So if I just quickly rub all of this out, we can then move on to question 3. So question 3 looks at find the values of x. This is where we are solving the equation. So if I just choose another colour, just black. Right, so for number 3, we've got here 5x to the power something 5x to the power of x, equals 1 over 125. So what we need to do is we need to write this as a power of 5. So 125 is 5 cubed, so we've got 5x equals 1 over 5 cubed, which then becomes 5 to the minus 3 because we've got the reciprocal. So therefore x equals minus 3. For B, looking at this, the key thing here is we've got powers of 3, and you want to think to yourself, well, can I write 27 as a power of 3? Which I can. So if I write, so knowing that 27 is 3 cubed, then I can write this as 3x times 3 to the power of 5 over 3 to the power of 7 equals 3 cubed. Now looking at this, we add the powers and we take away from 7. So what we've got is now I'm just going to rub this out just because I realise my writing's a bit too big. The spatial awareness is not great, so I'll just rub that out. I'll write that again. So we've got 3x times 3 to the power of 5 over 3 to the power of 7 equals 3 cubed. And just get rid of all that. So then from here, if we look at the rules of, oh no, I'm doing it. So looking at this, what we do is we add the powers because we're times in it, we take away from 7. So what I've got is I've got x plus 5 take away 7 equals 3, because obviously they've all got 3's and this is dealing with the powers. So if I just cancel those 3's, I'm just there for the powers, and when we times and we add, when we divide it, we take away, so I end up with this. So I've got x minus 2 equals 3, leaving us with x equals 5. Then following on from here, we've got with C, now again multiplying at the powers, we've got 2 to the 3x because we times that out. Now if I write 64 as a power of 2, I get 2 to the power, and again using my fingers on this one because I still do, there's nothing wrong with that. So we've got 2, 4, 8, 16, 32, 64, which is the power of 6. So the powers, as the bases are the same, the powers must be the same. So I've got 3x equals 6, so x equals 2 as your final answer. Now moving on to question 4, so this is where we kind of get to more advanced GCSE, or those who've done further maths would have covered some of these questions, is what happens when your base numbers aren't the same. Now when you have got this, it's not a trick, it's not mistaking the question, it's just getting you to think that a little bit more outside the box. So looking at number 4, now with this, what we've got is we've got base number of 8 and base number of 16. So what you want to kind of think of is when you get these questions is think to yourself, can I write the largest base number as a power of the smaller base number? Now in this case, unless we start going into fractions, there's no way there's no 8 to the power of something gives me 16 without it being a fraction. So we need to think smaller. So one thing you should note in terms of here is that I can write both 8 and 16 as a power of 2. So 8 is 2 cubed and 16 is 2 to the power of 4. So writing these in this notation here, what I end up with is 2 cubed 2x equals 2 to the power of 4 to the power of x minus 2. Now from this we multiply out the powers. So for example, I'm just going to deal with that and that, and because the base numbers are going to be the same, the only thing that must differ is going to be the powers. So what I end up with is 6x equals 4x minus 8. Solving this simple equation, I get 2x equals minus 8, so x equals minus 4. So again, key thing to remember is just try and change the base numbers. Sometimes it might be easier, but sometimes you might need to change both rather than one. Lastly, we move on to question 5. A question like this simply came up on a mock exam that students did, and what they tried to do was they got the right answer, but because their working out was wrong, they didn't get the marks in the exam. So let me just talk you through how we do this type of question with regards to question 5. Now, with question 5, we've got to write 144 as something like very similar to products of their primes of working through this. So with this, we've got to how I'd approach this question now. For some of you, it'd come quite commonly. We're just looking for two numbers that multiply to 144. One is going to be can be written as a power of 3, and one can be written as a power of 4. And we've got to work out what those powers are. So how I'd start with this question is just write down, and again, if you're doing this for the first time, this is how I would explain how we get this answer. 81. So I'm going to stop with regards to 3 to the power 4, and then regards to 2 to the power 1, 2 squared, 2, 3, 2 to the power 4, 2, 5, 2, 6, 2, 7. And we've got 2, 4, 8, 16, 32, 64, 128. So what I need to do is find out which sets of these numbers multiply with one of these that would give me 144. So I'm thinking, right, well, 3 times any of these gives me 124. No. 9 times any of these numbers, yes, it'll be 16. So from this, I know that 9 times 16 gives me 144, and from that I can then go for converting the 9 and the 16 into powers of 3. So for example, I can write this as 3 squared times 2 to the power of 4. So therefore P is going to equal 2 and Q is going to equal 4. So hopefully those range of questions will make some of the questions that you attempt a little bit easier. Like I said, I'll post up some exam style questions for you to have a go at. I'll post up the answers to make sure you're doing it right. And should you have any problems, do not hesitate to get in touch. Thank you for listening. Thank you for watching. And I hope you are now a lot more confident when it comes to working with indices.